So this part of the A-level days was thermochemistry, which for us at A-level means measuring delta H in the lab. Now it doesn't matter which delta H you're measuring, the experimental and calculational process is very much the same. And that's one of the things I really want to emphasize as we're going through these three different types of delta H that we measured, that essentially once you get past what's happening, everything is the same. Everything involves a calorimeter. Now the way that we work this is, of course, we put water in the calorimeter and we do our chemical reaction which affects the temperature of the water. So in our calorimeter we need to have a thermometer and a stirrer and get a way to measure the temperature change on the water. If our chemical reaction produces heat, the water goes up in temperature. If on the other hand our chemical process needs heat, is endothermic, then it will get that heat from the water and the water's temperature will go down. Once we've measured the temperature, now we can go ahead and do our calculations. And the first calculation is to get the heat change, Q, for the water. And the heat change for the water is always the mass of the water, which we can measure, times the temperature change, times 4.18 joules per gram per degree Celsius, the specific heat of water. Now, of course, the whole idea is that we're using the water to indirectly measure the heat change for our chemical reaction, because whatever happens to the water that we can measure and calculate, the opposite happens for the reaction. So therefore the Q of the reaction, the heat change associated with the reaction that we did, is minus the heat change for the water. And then, of course, as chemists, we never just say, hey, our reaction produced 10 joules. We always have to have it so many joules or kilojoules per mole. So the last step we have to do is to convert things to per mole. Now, I want you to take note of the colors that I'm using throughout here. The red box, setting up the calorimeter, we'll probably never see again. The blue here, now there's two blues that are going on. There's this glorious royal blue that is associated with water, and I'll use that throughout to illustrate how we're getting the mass of the water, not as trivial as it may sound. And then this other blue, which is vaguely the same as the color of the blue box, is always going to be associated with the temperature change of the water. This lovely green color is going to be associated with the calculation of heat for the water. The gold color is going to be associated with the heat for the reaction. I'll never really need to use a gold box again, because once I've got my answer in the green box, I just change the sign to get the Q for the reaction. So that will always be given as a gold, this gold, sort of goldy yellow brown color. And then finally, all the calculations associated with going from our measured heat to the per mole heat going to be in this sort of purple color. Okay, so really want to emphasize that it's the same throughout, the same fundamental process throughout, regardless of which delta H you're measuring. And you're going to measure, or calculate at least, three delta H's. First was the heat of combustion. We didn't do this because it's just kind of boring. Plus we don't actually have flames in our chemistry lab, deliberately so, because there's some safety hazards associated with naked flames. So we're not even plumbed in for natural gas. The only time that's been an issue is when we do flame tests. So we just have a blowtorch for that. Anyway, so first of all, heat of combustion, and we're going to do a heat of solution, determining the heat change when we dissolve ammonium chloride in water. And then finally, we're going to do a heat of reaction. We're going to look at a neutralization reaction and determine the heat of reaction. But again, process all the way through, overall the same.